Welcome to Easy BTech, your guide for BTech and beyond. Today we will discuss regarding volt ampere characteristics of FET. Okay, this FET characteristics are classified two types. FET characteristics are classified into two types. Number one, transfer characteristics and second one is output characteristics okay. FET characteristics are classified into two types. They are transfer characteristics and output characteristics. Now we will discuss what is transfer characteristics. Transfer characteristics means gate, drain, source. IDS, VGS, VDS, VGG. Okay, this is JFET. Okay, this is an n-channel JFET. Now you can see this is a basic characteristics. In the transfer characteristics, what you have to do, we can plot a graph between output current versus input voltage. Okay, remember the circuit. In the transfer characteristics, we can plot a graph. We can plot a graph between output current versus input voltage. Okay, now we will see the graph may be like this. VGS, VDS and IDS. Okay, when VGS is 0, when, okay, for your better understanding, see here, this is an N channel. Here ohmic contact. This is a source. This is a drain. P plus P plus. Both are overlap. This we will got as a gate. Okay. Here to here voltage we will call as a input voltage VGS, and here to here voltage we will call as a VDS. Okay. This is VDS. Now you can say when VGS is 0, when VGS is 0 and VDS is constant, VDS is constant, then what happens? Now in the diagram you can see when VGS is 0, this voltage is 0. Okay. When this voltage is 0, there is no change in the width of the depletion region. There is no change in the width of the depletion region. Depletion region width remains constant. Is it clear? But the amount of current flow depends upon this voltage. The amount of flow of electrons, depends upon this output voltage VDS, because a negative voltage is applied here and a positive voltage is applied here. Okay, students. Now you can see here clearly. When VGS is 0, VDS is constant. This constant may be at 1 volt. When VGS is 0 and VDS is at 1 volt, now you can note down the reading of IDSS. You can note down the reading of IDSS. Now you can take this reading. This has like 5 milliampere. Okay. Next, when VGS is now you may change now 1, like 2, 3, like that, keeping VGS as 0, and by changing the output voltage VDS at 1 volt, 2 volt, 3 volt, you may get different class. When VGS is 0 and VDS is constant at 1 volt, you will get the current as IDS as 5 milliamperes. Assume. Next, when VGS is 0 and VDS is plus 2 volts, then you might get 7 milliamperes. Next, VDS is plus 5, you will get like 10 milliamperes. Is it clear? It means the IDSS will depends upon output voltage, and there is no change in the depletion region width. There is no change in the depletion region width. The width of the depletion region becomes same, but the current flow in the channel will depends upon output voltage. Is it clear? When VGS is 0, current is maximum. When VGS is 0, current is maximum. Current is maximum. Okay, in the graph you can clearly study. Now keep VGS 0 at VDS at 1 volt. Now you can change. Now suppose you can take the reading as, now VGS is minus 1. If VGS is minus 1, now you are keeping VDS at 1 constant. Now the current is decreased. In place of 5, it will becomes like a 2 milliampere. Minus 2, VDS is constant at 1 volt. Then you will get like the current will be like 1 milliampere. Now at a minus 2.5 VGS, VDS 1 volt, VDS may be 1 volt, it is a constant. Now you will get a 0 here current, because you can see in the graph, by keeping this voltage at plus 1 constant, this VGS is 0, then automatically what happens? The current flows from, the electrons flow from source to drain, and current flows from drain to source. But as VGS is increased, then the depletion region width increases. This depletion region width increases. Okay, students? Next, now in this you can see here. Okay. Now we will take by keeping clearly by keeping VDS constant, take reading between IDS versus VGS. Take reading between IDS versus VGS. Okay, by changing VGG. Okay, by changing VGG, note down the reading between VGS and VDS. Now you are increased. VGS become 0, -1, -2, -3. But at one particular time, the depletion region completely overlaps. At one particular time, the depletion region will completely overlap. Depletion region will completely overlaps. Then no flow of charge carriers. And this width may be in this manner. Is it clear? Like this. This point. From this point to this point we will call as a change in L. This we will call as a channel length. Now this is now the total length is here to here. It is a total length. It is a total length. Now it is change in length now. Change in length. Now the length from this point to from the drain point. Okay, the pinch off voltage from the drain point, it is moving to the this change in length point. Then channel length modulation occurs. In FET, channel length modulation takes place. Channel length modulation occurs. Channel length modulation occurs. Okay, students, if you take a graph, the graph may be, now you can see, we can plot a graph. This is IDS, this is VGS, because VGS is negative, this is 0. Now at this point, now this current we will call as IDSS, drain saturation current, drain saturation current. Now this point is when IDS, when VGS is equal to VP, IDS is 0. When VDS, this point is nothing but pinch off voltage. This is at VDS 1 volt. This is at VDS 1 volt. Like that you may change. Now VDS you are taking second constant. Now it may shift from here to here. This is as VDS 2. Next 3. This is VDS 3. It means we can take a different graph by taking VDS at different interval. Now here what you can see, when VGS is 0, now here it is 0. When VGS is 0, you can see here, when VGS is 0, the current is maximum. When VGS is 0, IDS is equal to IDSS, maximum saturated current, maximum current. Now you can see when VDS is 1, when VDS is 5 volts or 3 volts. Now you can see this is a 3 volts, this is a 2 volts, this. Now you can see here when VDS is 3 volts, now it has maximum IDS. Okay students, where it reaches to the current we will call it is a pinch off voltage. From that relationship you can find IDS is equal to IDSS 1 minus VGS by VP whole square. This is a drain saturation current, drain current, okay. Here we can clearly study IDS is equal to IDSS 1 minus VGS by VP whole square. Okay, now here IDS is the drain output current, drain current. Next IDS is the drain saturated current, drain saturated current. VGS is the input voltage, VP is the pinch off voltage, VP is the pinch off voltage. Okay students, now you can clearly see this is a graph IDS versus VDS. When VGS is 0, IDS is maximum, that we will call as an IDSS. This point we will call as an IDSS. This is a transfer characteristics, plotting a graph between IDS versus VGS. IDS versus VGS we known as a transfer characteristics. Now we will see the output characteristics. In an output characteristics, in an output characteristics, okay, same the structure here. Gate, drain, source. IDS, V, VDS, V naught, VGS, VGG. Okay. Now here to study the output characteristics, we can plot a graph between output current versus output voltage. Plot a graph between output current versus output voltage, keeping this VDS constant, keeping VDS constant. So that we will see. Okay. Output characteristics. Plot a graph between IDS versus VDS, keeping VGS constant, VGS constant. Now the graph may be like this. This is IDS, this is VDS. Now you can see This is IDS, this is VDS. This region is known as ohmic region. Ohmic region. Okay. This is we will call as a pinch off region. Pinch off region. After this, you will take this point we will call as a breakdown region. Breakdown region. And this voltage is nothing but pinch off voltage. These are output characteristics curve. Okay. Plot a graph between IDS versus VDS. Now you can see this keep at 0 by keeping this VGS 0. Now change this VDD. Change VDD. By changing VDD, note down the reading of IDS and VDS. By changing VDD, note down the reading of IDS and VDS. Is it clear? Now you will get one value. This graph you will get. This the first graph you will get. And the second, again keep this VDS by changing VDD, or first VGS you can keep now into -1. VGS you are keeping -1. Now change the VDD and note down the reading of IDS and VDS. Then you will get the second graph. This. It means as VGS, this is as VGS 0, this is at VGS -1, this is at VGS -3, this is at VGS minus. Like that, at different values of VGS, the current is gradually decreasing, you can see. Okay, where a current is increasing, linear region, where current is increasing, it means from when VDS less than VP, when VDS less than VP, it is a linear region, the current is increasing. When VDS greater than VP, when VDS greater than VP, it is a saturated region. Saturated region. Saturated region. Or we will call it as a pinch off region. Pinch off region. The current almost the current is constant. Almost the current is constant. That is why a FET can act as a constant current source. A FET can act as a constant current source in the pinch off region. When VDS is greater than pinch off, then when output voltage VDS is greater than the pinch off voltage, then the transistor is operated in pinch off region, then the FET is known as a constant current source. And when VDS is going on increasing, then breakdown can occur. A huge current can flow through the transistor. Just a breakdown can occur in FET when VDS is maximum. Okay, students. This is about input-output characteristics of the FET. Easy BTech, guide for BTech and beyond. Thank you.